A molecule is an electrically neutral group of two or more atoms held together by chemical bonds. Molecules are distinguished from ions by their lack of electrical charge. However, in quantum physics, organic chemistry, and biochemistry, the term molecule is often used less strictly, also being applied to polyatomic ions. In the kinetic theory of gases, the term molecule is often used for any gaseous particle regardless of its composition. According to this definition, noble gas atoms are considered molecules despite being composed of a single non-bonded atom. A molecule may be homonuclear, that is, it consists of atoms of a single chemical element, as with oxygen. Or it may be a chemical compound composed of more than one element, as with water. Atoms and complexes connected by non-covalent bonds such as hydrogen bonds or ionic bonds are generally not considered single molecules. Molecules as components of matter are common in organic substances. They also make up most of the oceans and atmosphere. However, the majority of familiar solid substances on Earth, including most of the minerals that make up the crust, mantle, and core of the Earth, contain many chemical bonds, but are not made of identifiable molecules. Also, no typical molecule can be defined for ionic crystals and covalent crystals, although these are often composed of repeating unit cells that extend either in a plane or three-dimensionally. The theme of repeated unit cellular structure also holds for most condensed phases with metallic bonding, which means that solid metals are also not made of molecules. In glasses, atoms may also be held together by chemical bonds without presence of any definable molecule, but also without any of the regularity of repeating units that characterizes crystals. Molecular science, the science of molecules, is called molecular chemistry or molecular physics, depending on whether the focus is on chemistry or physics. Molecular chemistry deals with the laws governing the interaction between molecules that results in the formation and breakage of chemical bonds, while molecular physics deals with the laws governing their structure and properties. In practice, however, this distinction is vague. In molecular sciences, a molecule consists of a stable system composed of two or more atoms. Polyatomic ions may sometimes be usefully thought of as electrically charged molecules. The term unstable molecule is used for very reactive species, that is, short-lived assemblies of electrons and nuclei, such as radicals, molecular ions, Rydberg molecules, transition states, van der Waals complexes, or systems of colliding atoms as in Bose-Einstein condensate. History and etymology. According to Merriam-Webster and the online Etymology Dictionary, the word molecule derives from the Latin moles, or small unit of mass. Molecule extremely minute particle, from fr molar copyright ~cuel, from modern Latin. Molecular, diminutive of Latin moles mass, barrier. A vague meaning at first. The vogue for the word can be traced to the philosophy of Descartes. The definition of the molecule has evolved as knowledge of the structure of molecules has increased. Earlier definitions were less precise, defining molecules as the smallest particles of pure chemical substances that still retain their composition and chemical properties. This definition often breaks down since many substances in ordinary experience, such as rocks, salts, and metals, are composed of large crystalline networks of chemically bonded atoms or ions, but are not made of discrete molecules. Molecular size. Most molecules are far too small to be seen with the naked eye, but there are exceptions. DNA, a macromolecule, can reach macroscopic sizes, as can molecules of many polymers. Molecules commonly used as building blocks for organic synthesis have a dimension of a few angstroms to several dozen A. Single molecules cannot usually be observed by light, but small molecules and even the outlines of individual atoms may be traced in some circumstances by use of an atomic force microscope. Some of the largest molecules are macromolecules or supermolecules. Smallest molecule diameter. The smallest molecule is the diatomic hydrogen, with a bond length of 0.74 A. Largest molecule diameter. Mesoporous silica have been produced with a diameter of 1000 A. Radius. Effective molecular radius is the size a molecule displays in solution. The table of Palm selectivity for different substances contains examples. Molecular formula. A compound's empirical formula is the simplest integer ratio of the chemical elements that constitute it. For example, water is always composed of a 2-to-1 ratio of hydrogen to oxygen atoms, and ethyl alcohol or ethanol is always composed of carbon, hydrogen, and oxygen in a 2-6-1 ratio. However, this does not determine the kind of molecule uniquely. A dimethyl ether has the same ratios as ethanol, for instance. Molecules with the same atoms in different arrangements are called isomers. Also, carbohydrates, for example, have the same ratio but different total numbers of atoms in the molecule. The molecular formula reflects the exact number of atoms that compose the molecule and so characterizes different molecules. However, different isomers can have the same atomic composition while being different molecules. The empirical formula is often the same as the molecular formula but not always. For example, the molecule acetylene has molecular formula C2H2, but the simplest integer ratio of elements is CH. The molecular mass can be calculated from the chemical formula and is expressed in conventional atomic mass units equal to 1/12 of the mass of a neutral carbon-12 atom. For network solids, the term formula unit is used in stoichiometric calculations. Molecular geometry. Molecules have fixed equilibrium geometries bond lengths and angles about which they continuously oscillate through vibrational and rotational motions. A pure substance is composed of molecules with the same average geometrical structure. The chemical formula and the structure of a molecule are the two important factors that determine its properties, particularly its reactivity. Isomers share a chemical formula but normally have very different properties because of their different structures. Stereoisomers, a particular type of isomers, may have very similar physico-chemical properties and at the same time different biochemical activities. Molecular spectroscopy. Molecular spectroscopy deals with the response of molecules interacting with probing signals of known energy. Molecules have quantized energy levels that can be analyzed by detecting the molecule's energy exchange through absorbance or emission. Spectroscopy does not generally refer to diffraction studies where particles such as neutrons, electrons, or high-energy X-rays interact with a regular arrangement of molecules. Theoretical aspects. The study of molecules by molecular physics and theoretical chemistry is largely based on quantum mechanics and is essential for the understanding of the chemical bond. The simplest of molecules is the hydrogen molecule ion, H2+, and the simplest of all the chemical bonds is the one-electron bond. H2+ is composed of two positively charged protons and one negatively charged electron, which means that the Schrödinger equation for the system can be solved more easily due to the lack of electron repulsion. With the development of fast digital computers, approximate solutions for more complicated molecules became possible and are one of the main aspects of computational chemistry. When trying to define rigorously whether an arrangement of atoms is sufficiently stable to be considered a molecule, IUPAC suggests that it must correspond to a depression on the potential energy surface that is deep enough to confine at least one vibrational state. This definition does not depend on the nature of the interaction between the atoms, but only on the strength of the interaction. In fact, it includes weakly bound species that would not traditionally be considered molecules, such as the helium dimer, He2, which is one vibrational bound state and is so loosely bound that it is only likely to be observed at very low temperatures. Whether or not an arrangement of atoms is sufficiently stable to be considered a molecule is inherently an operational definition. Philosophically, therefore, a molecule is not a fundamental entity. Rather, the concept of a molecule is the chemist's way of making a useful statement about the strengths of atomic scale interactions in the world that we observe. See also. References. External links, Molecule of the Month, School of Chemistry, University of Bristol.